When we want to capture a packet from the network interface, the first thing we have to do is to obtain the list of interfaces on our machine. In here I have identified all the network interfaces and get their details. We have to capture the all network interfaces. So we have to first we have to import the JPCAP library. It provides the JP capture class, and it contains the method called get device list that will returns the network interfaces array. Each network interface object contains some information about corresponding network, such as the description name, device description, data link name, data links description, MAC address of the each interface. It is a hexadecimal number, and converts the destination number, and the device IP addresses of the each device. In here we can see the device name is this, description is this, and Ethernet data link name is this, data link description is Ethernet, MAC address, two IP addresses, IPv6 address and the IPv4 address, subnet mask, and broadcast address.
The method open interface tries to open each interface which has been detected. It tries to achieve this by calling the method open device, which has been provided by the JPCAP library. This method takes in 4 parameters, including the network interface which it tries to open, the number of bytes which it tries to capture, a boolean indicating whether it opens the network interface in promiscuous mode or not, and finally the capture timeout value in milliseconds. In promiscuous mode, you can capture any packet regardless whether the source or the destination MAC address being the same as the MAC address of the machine itself. After capturing packets from that network interface, the method tries to close the JPCaptor instance and returns it.
I am Sadari Javardhana, index number 090229P. The method I wrote read a data link layer and network layer header details of a captured packet. This method is responsible for printing packet details. This first line converts the packet into Ethernet packet. This section checks whether the packet is IPv4 or whether it's IPv6. This section reads the source MAC address of the Ethernet packet. Since in Ethernet packet the MAC addresses are given in byte array form, this for loop converts it into a string. Similarly, this section reads the destination MAC address. This line converts the packet into IP packet. These two lines reads the source IP address and the destination IP address from the IP header. This is how the details are displayed in our GUI.
I am HMAB Herat 090178G. In our application, I introduced the functionality to display the packets details in this table. To do that, I used this add packets method. The add packets method is called from the packet handler. After capturing each packet, it will be called per packet. What it does is it takes the row count from the model. Model is the table model that is in this design, and then so because the row count is the row number of the new row added, then to that row, to each column, packets details will be added. The details added are packets type, source and destination MAC addresses, source and destination IPs, and packets data. To take this data from the packet, I can use this packet dot get type, packet dot source MAC, etc. And the values I get are displayed using the set value at method. So in our application, I introduced the functionality to display packets details in this table.